welcome back. In this section, we're talking about some more advanced object-oriented principles. So I've created this sample project here called Advanced OOP, just a small project where we're going to create a few files to explain a couple of these concepts. There are two files in here right now. We've got user.py, and in this file, all we have is a short class that represents a user. So you've got an init method, takes in a username and a password, and sort of sets them as the properties of the object you've created. And then it has two other methods. A login method just returns that you've logged in. Potentially this should do something like check a database, compare the password that you've given with the password in the database or something like that. And it's got a repr method. Fairly normal class, you'll create things like these all the time in your project. And then we've got an admin.py class, and this inherits from user. So it takes in all of the methods of the user. And then what we've got is another init method in this admin class, takes in a username, a password, and an access level. And then that calls the user's init and sets the access level property. Potentially, this access level could be something like super user or manager or something like that, different levels of admin privilege. Then the repr method here has the admin, username, and the access. And finally, it also includes a toDict method, which returns a dictionary representation of this admin object. So it returns the username as self.username, password as self.password, and access self.access. Just returns a dictionary, and using this dictionary, we could recreate the object. So this is similar to, for example, if you wanted to save this to a database, you would just take each of the properties in this dictionary, you could put them in a database, for example. Now, let's say that we do want to create some sort of database. I'm going to create an in-memory database file, call it database.py, and just code it live in front of you, because I think this is an interesting thing to go through. In creating this database, we're then going to use it to explain how multiple inheritance works. So I'm going to create this class database, and the database class is going to have a class variable called content. And a class variable is just a variable that exists within the class as opposed to within the object. So you can access this as database.content, and it'll always give you this dictionary. Then we're going to have a couple of methods, a couple of class methods. Insert, that is going to take in some data and is going to insert it into database.content, users, append data. So again, database.content is this dictionary here, and all we're doing is we're appending to the users list whatever data we received in the insert method. Because this is a class method, we can of course replace database by CLS, since CLS and database are the same thing. Then we're going to have another class method that is going to be remove. And this is going to take in a finder function, and all it's going to do is it's going to do cls.content users equal user for user in cls.content users, if not finder user. Pretty, standard way of removing something from a list. Do a list comprehension and put all the elements of that list into a new list for as long as they don't match this finder function. So the finder function potentially could be something like lambda x username is not Rolf. So this could be the finder function, and then if it doesn't match that, we will remove it. Finally, just for completeness, and because of course we will need this, let's add a final class method, which is going to be a find. Okay, and this is going to return user for user in CLS content users, if finder user. So this time it's going to find all the users that match the lambda function. So again, lambda x username is Rolf. This is going to find all the users in the database that do match this lambda function. So it's going to find all the users that have username of Rolf. Okay. This is our sample database. So when we import this class, it's going to initialize this content variable, and then we can insert, remove, or find data within this class variable there. Notice that if we create multiple objects of type database, they're all going to have the same content variable. This variable is a class variable, it's not an instance variable, so it doesn't change per object. All objects have the same instance variable. So, going back to our admin.py, let's say we want to insert this into our database. What could we do? Well, we could say something like save, and then do something like database.insert self to dict. Yeah, we'll have to import database as well. Okay, this is the save method implemented into our admin. Now, if we created another file, let's call it app.py, and we wanted to test this out, test the admin out by creating an object and saving it to the database and then maybe finding it back, we could do that. We can import the admin class, say that A is an admin, Rolf and 1, 2, 3, 4, and the access level is going to be, let's say, 3. Then we can do a.save, and then we can do print database.find lambda x username is Rolf. We'll of course have to import database as well. Okay, let's run app.py. And as you can see, we get back what you'd expect, the result of this database.find. So that's well and good. What if we wanted to create, another thing that we could save to the database? Let's say, for example, we wanted to create something like a store.py. This is going to be some class store, and it's going to have all its stuff, and then it's going to have a toDict, and that is going to do something, and it's going to have a save, and that is going to do database.insert self.toDict. As you can see, we've got some duplication between admin and store. There is one thing that is fully duplicated and one thing that is partially duplicated. The one thing that's fully duplicated, and the thing we are going to solve in this video, is this save method. The save method is fully duplicated between admin and store. So as you can see, you've got this save and it's database.insert self.toDict. And in the store, you've got exactly the same thing. Def save, database.insert self.toDict. So in both cases, the save method, all it's doing is it's taking the current object, whatever object you're talking about, be it a store or an admin, it's converting it into a dictionary using its toDict method, and then it's putting it into the database. Same thing, same code. The thing that's partially duplicated is this toDict method. As you can see, both admin and store have a toDict method, but the implementation of the method, what it does, is different between both. The store here will probably return, I don't know what items are in it, or the name of the store, the address, etc. The admin is returning the username, password, and the access level. But as you can see, they both have a toDict. So throughout the next section, we're going to learn these techniques that are going to allow us to reduce this duplication and also improve the stability and the consistency of our programs. In order to solve this save problem, we could do, of course, one thing. The first thing we could do is we could cut it from there. If we wanted to remove it from the admin class, and we could put it into user, right? Now, of course, we'll have to import database from here, in order to make that work. But the truth is the store does not inherit from user, so it's not going to have that toDict method available. That save method available. So we don't want to do that. What we want to do is have a third class, or rather a fourth class, that contains this save method only. So I'm going to go and do just that. I'm going to create a new Python file. I'm going to call it savable.py, and there's a reason why I'm calling it savable.py, and as I'll explain later on in the course. And this is going to be some class savable, and all it's going to do is it's going to implement this method. So we have to import that. Notice how it says, I don't know what a toDict method is because we don't have it defined inside this class. And we are going to fix this later on in the section. But for now, all we need is to go over to admin. No longer need to import database here, but from savable, import savable. And now after user, include savable there. Now we no longer need to import database. We don't need a save method there. Remember, inheritance is very similar to copying the code and putting it into this class. So as soon as you inherit from both user and savable, all that Python does is when you call a method like self.save, it goes to user, tries to find that method, and if it doesn't exist in user, then it goes to savable and it tries to find it there. So it's going to find self.save inside this superclass, and it's going to call it, but it's going to be able to find self.toDict in the admin class. So again, self.save will be searched in admin, then in user, then in savable, where it will be found. Self.save uses self.toDict, and again, self.toDict will be searched for in admin, where it will be found. And that's it. So there's a tree of sort of method calls that happens when you have inheritance, and that's the first class that you inherit from. The one at the left is, well, of course, the class you're in is the first one that gets searched, and then the one at the left, and then the one next to it, and so forth. So by using multiple inheritance like this, you can actually extract functionality that is shared amongst similar objects and similar classes like user to admin, but then also between more abstract classes, like savable class isn't a user, it could be anything in your application. So you can extract specific bits of functionality into a class like this one. Of course, it's not great because you've got this unresolved attribute reference. So we're going to look at how to fix this very soon. Again, if you run app.py, you'll see that it all works fine. It doesn't complain. It doesn't give you an error because exactly what I said earlier is what's happening. The save method is in savable, the toDict method is in admin, and they all sort of work together. That's it for this video. I wanted to give you a quick intro to multiple inheritance, and I'll see you on the next one. Hi and welcome back. In this video, we're going to talk quickly about ABCs. ABCs are pretty useful in Python because they let you define some functionality without implementing it. We're going to leave our users and admins for a moment and create a new file that I'm going to call animals. And this is going to be maybe a not great example on using ABCs in a real project, but just a quick overview of how they work. Then we're going to use ABCs on the rest of our code. So let's say we've got a class dog, for example. And this, you can initialize it with, let's say, a name. And there is something that all dogs, or at least the large majority of them, have in common, which is the number of legs, let's say. In a dog, let's say that this is going to return 4 at all times, okay? So, not the most useful method for any class. This might as well be a property of the dog, or maybe a class variable there. But nonetheless, let's define it as this method. Now, if you wanted to define another class let's say, a monkey that also has, let's say, a name and also has a num legs, let's say that now returns 2. You've got, a bit of a problem. Before we said you can extract functionality into a class, like, some animal class, and define some functionality here, and then return something. And then you could make the dog extend from animal, right? And then you could delete this method. But you cannot do the same thing with the monkey because the monkey has 2 legs, not 4. So how do you do this? Well, here's where ABCs come into play. Let's say that you have a bit more functionality for each animal that you want to make available to all animals. Let's say, for example, a walk method. And this walk method is going to return or print walking. Of course, this could be something a bit more useful in a real program, but nonetheless, just an example. Now you want both your monkey and your dog to extend from animal so that they can both use this method, walk. But you don't want the numLegs method to be 4 for both animals. So, what to do is to cut it again. Oh, by the way, let me just say that this would do what you want. This current status of the code, defining numLegs in the animal class, the dog would inherit that and it would return 4. The monkey would override the method and it would return 2. So this works. But there is a problem, which is that you can now say that you can create a new animal. And then you can print a.numLegs. And that's just kind of weird because not all animals have 4 legs. But if you run this file, you'll see that your animal class that isn't a specific animal, it's not a dog or a monkey or a cat, it's just this abstract animal class, returns 4 for the number of legs, which doesn't make any sense because animals don't always have 4 legs. So what to do is to cut that and put it back into the dog. Now, of course, if we say a is animal and print a.numLegs, it gives us an error because it says, I don't know what that is. So that's fine. But if you have a dog and a monkey and potentially, let's say, a whale, the whale will have some code here, and the monkey will have some code in here, and the dog will have some code in here. And just by looking at the class and the inheritance tree, you don't know whether they have a numLegs or not. The whale should probably not have numLegs. Or maybe it should be 0. Maybe whale should not inherit from animal, it should inherit from something else. So what I mean to say is, just by knowing that these two are animals, you don't know that they have numLegs. But it could be interesting for you to know that. So here comes the ABCs. Let's do from ABC, import ABC meta and abstract method. And then we're going to make our animal class inherit, but in a slightly different way, from ABC meta. Now, ABC meta is a real class, but it allows us to do some things that normal classes don't allow us to do, and that's using this abstract method. Now, one of the great things of having this abstract base class, this is what ABC mean, abstract base class, is we can do abstract method and then define our numLegs method and then do something like pass. Okay, so now we've defined this abstract method and we've said animal has this method numLegs, but it's not about a specific animal in the world, it's a bit of abstract. It doesn't refer to anything concrete. So then it is the responsibility of the child classes, like dog and monkey, to implement that method. Now if we run this code, if we run animals, we'll get an error. And it says, can't instantiate abstract class animal with abstracts methods numLegs. Python doesn't let you create an object of type animal anymore, because it realizes that an animal isn't a thing in your program. An animal is something that you've used to extract functionality and to give you a bit of information, but it's not something that you'll want to interact with directly. So it doesn't let you instantiate an animal class because it doesn't make sense to do that. You'll instantiate specific animals like dogs or monkeys. So this is how you use an ABC, an abstract base class, and how you define an abstract method. If any of your subclasses don't implement the abstract method, you won't be able to create objects either. So if you delete this from the dog class and then try to create a dog, and then you print num legs, it won't let you. So let's delete that, run animals again, and it says you can't do that. But as soon as you have this method in here and you run it, now you can, and you get 4 back. So abstract base classes can be quite useful in a number of scenarios in order for you to know that the subclasses will all have this method. So you know that whenever you have a subclass of type animal, this method will be available. Let's expand a little bit on why this is useful in the very next video. I'll see you there.
I've noticed this, that beyond the material ego, there is now suddenly a widespread.
Who's this ego guy, your friend?
It's all around me.
Show me where it is, I'll fix it right now.
I wish I knew where it was, it just keeps coming suddenly.
No, you don't know where it is. Certain moments maybe you're nasty. But if you say, whenever you're nasty, Mr. Ego does this, and you don't know where he is, you don't know his address or ID, nor do you know his phone number, so how do you fix this guy? That don't talk about Atma, Paramatma, ego, this one, that one. You are an individual. What kind are you? Are you a wonderful one or a nasty one? Fix the damn thing.
Hi and welcome back. In this video, we're going to briefly talk a bit more about ABCs and why it can be useful to have this functionality, numLegs, defined in another class that isn't either of your child classes. The main reason why you'd like this, well, there are 2 reasons. The first one is that when you read your code and you see, okay, dog is an animal, monkey is an animal, you'll know without reading all of the contents that they will have implemented numLegs. So you'll know that, otherwise you won't be able to use them. Or unless, of course, these are then subclassed by other things which implement the method. But generally, you'll know that they must have implemented the method in order for you to be able to instantiate them, create objects. The other thing that's really useful is that if you have a list of animals, for example, a dog, which is Rolf, and a monkey, which is Bob, you can do a.numLegs. See this? This is quite a magical thing, and it may not seem it just now, but what you've got here are 2 completely different objects in this list. But because you know they are animals, you can call a.numLegs on all of them. Okay, so let's run this again. Now you can see we get 4 and 2, which is as you'd expect. After all that's happening in the background is, A is this dog, call the numLegs method, you call this thing here, so nothing magical is going on. A is this monkey, so you call the numLegs method on that. Nothing magical, but nonetheless, the fact that you know that these are animals means that you can do this. Furthermore, you can print whether A is an instance of animal. We should not forget the commas. And you get true every time. This is the same for all inheritance in Python. A is an instance of animal, but it has also been extended by the subclass. So Python says, yes, this is an animal in that it has all the methods and the properties of the animal, but it can also have methods and properties of whatever it is that the class defined as well. The usefulness of this is for you to say, okay, these are all animals, therefore I can call animal methods on all of them, and I don't care whether they are more specific, whether they are dogs or monkeys or cats. Because they're animals, you can call the methods in them, and because you define this numLegs method on the animal, you know that all the subclasses must have implemented that as well, so it's safe for you to call it. Now let's go back in the next video to our users and our admins and make a little bit more sense on where this can be useful. As part of that, we're also going to be talking about what an interface is. I'll see you there.
Why don't cows drink milk and chicken eat eggs? Some of you going, whoa. Wow. No cow gives milk and goes, hey, I only do 2%. Cows don't do that. And no chicken goes, I like them over easy. They produce for somebody else. And look, here it comes. If you've got a gift to make money, that's not for you. I knew you'd get upset about that. That's okay. I knew. So if you've got a gift to sing, if you've got a gift to serve, that's not for you. That's for other people.
Hi and welcome back. In this video, I wanted to move that abstract class into our other code just to give you another example of where this can be useful. Going over to our savable.py, remember that it's got this save method that calls a toDict method, but the savable class doesn't have that method defined. However, it relies on a subclass like admin to implement the toDict method. Relying on the subclass to implement the toDict method is okay, but it's even better if you can force the subclass to implement the method. And now that you have ABCs and abstract methods, you can. So let's go ahead and implement this using an ABC. So from ABC, import ABC meta and abstract method. And now we can define the toDict method using this abstract method. We can say toDict and then just pass it, which means it doesn't do anything. Now, this is happy because it says, okay, I can see that there is a toDict method defined, but it doesn't actually do anything in this class. It only does things in the toDict. So the whole purpose of the abstract method is to force the subclass to implement the method that it needs. Again, the fact that we have this savable class now means that admin is an instance of savable. And that can be quite good if you want then a list of savable things. You can then call save on each of them, even if they are not all admin objects. If we cut the savable from here, and we put it into user.py, now user becomes savable, and admin is also a savable because it's a subclass of user. So again, admin has a toDict. So when we say some admin object dot save, it'll call admin's toDict. If we have some user object and we call save, it'll call the user's toDict, which doesn't exist, so we have to implement it. So just like that. Now the user has a toDict, admin has a toDict which overrides it, and they both can be saved by using the savable class. From now onwards, you can refer to savable as an interface. Oh, and by the way, sorry, I forgot to define this meta class there. This is important, of course, otherwise it doesn't make much sense. Python won't be able to understand what's going on. So savable here is a superclass because it's an abstract class. You can see it's a class here. In many other programming languages, this would be known as an interface because it defines the functionality that should be in a subclass. That's what an interface is. An interface is not a class that you can instantiate. It is a thing in programming that defines what a subclass must do. So in those terms, adhering to that definition, this is an interface. But because it has this save method that is actually implemented, we can't say that this is an interface in the traditional sense. However, I quite like these quote-unquote Python interfaces. I like them because you can define them as interfaces, just say subclasses must implement the toDict method. And you can also add some functionality that is shared amongst the subclasses, like the save method. In Java, for example, you can define interfaces as something that is separate from classes, completely different things. So you can define in Java things like these. The subclass must implement this method. But in Java, you cannot define, or at least you couldn't when I did Java a long time ago, you couldn't define the save method. You couldn't say the subclass will be able to do this as well and implement it. So pretty useful in Python that these interfaces can have both definitions of what the subclass must be able to do, must implement, and also provide some functionality that will be shared among subclasses. And this is what an interface is in Python. It's as close as you're going to get. You don't have defined interfaces like in other languages, like in Java, but you do have abstract methods and ABCs, which allow you to force subclasses to implement particular things. And then, of course, if we go into app and you have some users, you'll have to import user, of course. You can then naturally have a list of users and then save them all like that. This is perfectly fine because each user is a subclass or implements the savable interface. Because they all implement the interface, you know that they're all going to have this save method there. If you're not sure when you're going to use this, don't worry. The purpose of me teaching you about these advanced concepts in object-oriented programming is not so you'll immediately get some ideas on what to do with them. But as you develop more, maybe when you get a job doing Python development, or maybe if you already have a job and you're working more and more with Python, you will find yourself in a situation where this will be the perfect thing to use. And knowing about it is going to let you design programs much better. Of course, try it, give it a go, write the code, download the code that I've made available in this section, and play around with it so that you do internalize it. Otherwise, a few months down the line, you will have forgotten that this exists. And if you do encounter a situation where you'll need this, you won't remember. So make sure to play around with it and give it a go. And I'll see you in the very next video where we're going to talk about something else. I'll see you there.
Believe in yourself. When you think you can't do this, or you're just not good at it, is the time you need to believe in yourself the most. The way you look at yourself is the way the world will look at you. You can't change people's opinions. I'm pretty sure 50% of you might not agree with what I say or might not like me. But that does not change what I think about myself, do I? I come off as a very strong, confident woman. I know exactly what I get to the table, and that will never change. So your perspective about me might change or might not change, but it will never affect what I think about myself. And that's how you gain confidence.
Hi and welcome back. In this video, we're going to talk about property setters. Let's create a new file that I'm going to call flight. And in here, I'm going to just define a simple class that will be, a flight object. In case you don't know, flights are normally something that looks like this. It goes, for example, from Glasgow to London Heathrow. This could be a flight. And in this flight, you have one segment, A segment is essentially you getting on a plane and you landing somewhere else. If you're going from Glasgow to Toronto, you'll actually stop in London Heathrow in the middle. So you'll have something like this: Glasgow to London Heathrow to Toronto. So these are two segments. And the whole thing is known as a flight leg. So flight leg, in this case, has two segments: Glasgow to London Heathrow and London Heathrow to Toronto. Just a bit of background information. I am sort of getting a bit disillusioned with the animals and the friend example. So now that you know a bit more about Python, I wanted to give you some more interesting examples of things you can do. So let's create this flight class. I'm gonna not a wrapper, define an init method, and we're going to get a list of segments. So this is going to be a list of segment. Okay, we can import this, of course, and that just imports it. In PyCharm, you can press Alt-Enter if you're on Mac, or I think it's Control-Enter if you're in Windows, to get the type hints. And then we're just going to say self.segments equals segments. Down here, we're going to define the class segment, which is just going to have a departure and a destination. Okay, pretty simple class there. All it does is it has a departure, for example, GLA, if I can type, and a destination, let's say London Heathrow. So that just gets stored in this segment object, and we're going to get a list of segments passed over to our flight constructor. Then we're going to have something like a property that is going to be a departure point. So where does this flight begin? It begins in the first airport of the first segment. So that's where this flight is going to begin. So we're going to return self.segments 0.departure. Okay, and it's going to return a string. So this is the departure point. Now, if we wanted to overwrite the departure point, let's say make the flight depart from Edinburgh instead of Glasgow, there is no easy way to do that. So I'm going to, down here, write some code to do that. Okay, I'm going to say my flight is a flight object there that has, let's say, a single segment that goes from Glasgow to London Heathrow. Okay, so now we have a flight object that has a list of segments, but it only has one segment in there, and the segment is going from Glasgow to London Heathrow. If you print the flight departure point, notice how it's a property, so you don't need the method brackets, you'll get Glasgow, or GLA for Glasgow Airport. If you then want to make the flight depart from Edinburgh, you would have to do something like flight.segments 0.departure equal Edinburgh. Not terribly simple. I would rather do flight.departure point equal Edinburgh. But of course, we know departure point is a method. So this, can it be done? Can you do this? The answer is no, by the way. You cannot do this right now. But of course, Python knows that you may want to do this. And it provides you with another decorator you can use. The decorator is actually quite a magical thing now, because the decorator will be called departure point. So now we use @departure point, which is the name of our property, .setter. And then we can call our method the same thing if you want, or you can call it something else. And of course, it needs the value that you are going to pass in. That's the EDI down there. And then all we have to say is self.segments 0.departure equal EDI. Okay. An even better way of doing things, just because of the departure should be equal to val, of course, not EDI. An even better way of doing things is the following. Normally, segments are specific flights. They have specific flight codes and specific numbers associated with them. So you can't just say, this flight is now going to depart from Edinburgh. But what you can do is you can put a different segment in there altogether if you want. So I would rewrite this. So instead of doing this, just in a professional environment where your segments cannot change because they have specific flight codes associated with them, I would say the destination is self.segments 0 destination, and then I would say self.segments 0 is a new segment where the departure is val and the destination is dest, this thing we calculated up here. Potentially here you could also, find out what the flight code is going to be, find it in from a database or some other place and decide that there. The only reason I'm doing this is to show you again what you could do if you were not able to change the segments themselves. You could just create a new one, replace segments 0 for that. That would be fine. Okay. Now you can do this. So you can delete flight.segment0.departure equal EDI and now say flight.departure point equal EDI. And if you print flight.departure point, you'll see that when we run flight.py, yes, sorry, my bad. With the typing, you have to define this class before the other one. Just the way that Python sees the classes, it evaluates this method typing before it has imported the class. So you have to define that there. And then you can see that you get Glasgow and Edinburgh. In my notes, I actually don't have the typing defined in the methods. That's why I didn't realize this before. So as you can see, this helps you identify how to change the departure point. Now you don't even have to know when you're using the flight object that this is a property or not. So whether this is a @property decorated method or whether it's an actual property of the flight. This lets you set them and get them. Just for completeness as well, I'm going to define a repr method in order to show you how I would do this. This repr method has to return something, string in the format of Glasgow, London Heathrow, Toronto, for example. So how are you going to do this? How would you create a string that has this format, knowing the segments? I'd encourage you to give this a go, by the way. Pause the video and give it a go if you can. Hopefully you tried that. What I would do is say, get a list of the stops. So the first stop of your flight, or rather where it starts, is Glasgow. The second stop is the end of the first segment. So you've got start of the first segment, end of the first segment. Then you have the end of the second segment. And then if it was going somewhere else, you'd have the end of the third segment, and so forth. So the stops initially are self.segments0.departure and self.segments0.destination. These are the two initial stops that you know you're always going to have. You're always going to have segments0.departure and segments0.destination. Then I would say for seg in self.segments1 onwards, stops.append seg.destination. Simple enough. You start then at the first segment, or rather segment number 1, the second segment if there are any, and then you append the destination over to your stops. And at the end, you can return .join stops. I'm not sure if we've seen this before. All this allows you to do is join each of the elements of the stops list with this string. So it will essentially put the first stop at the start of the string, the second stop after the string, and then it will put another string after and put the third stop and so forth. So essentially creating a string that looks like this. Now we can just print the flight Instead of printing the departure point, we can run it again, and we can see that we've now gone from Glasgow to London Heathrow, over to Edinburgh to London Heathrow. And here we've learned about a few things, like the setter, and also how to use the setter in a property, and we've got some more practice at defining some actual real examples of code. That's it for this video. I wanted to show you how to use the setter in a property. So thank you for joining me, and I'll see you on the next one.